I'm going to do something that's going to seem pretty unwise to do at first. I'm going to take this unopened soda can and poke it with this pin. Okay? So here we go. Right about in the center of the can this way. You can hear it leaking out perhaps. Little soda came out, not much, because that's the little gas pocket on top. But I want to get all that soda out of that can now, so I'm going to turn upside down. And there it comes. Shaking it, of course, helps. I got a pretty good aim, huh? That takes a little while. So I've actually got this, we'll let this continue to drain there. It goes rather slowly if you're not continually shaking it. But the object is to completely empty the can of all soda, and this one's had that done. There's a little bit left in there, but that's okay. Then you want to take the same pin, and if there's the hole the first time, I'm going to make a hole exactly opposite it, okay? Maybe the camera can give a focus on that tiny hole. It's just a small pinhole. And now I'm going to put the pin back in there about halfway and push the pin to one side and pull it out. That hole is no longer going straight in and out, it's tangential to the can. I'm going to turn it over, do the exact same thing with the other hole, put the pin about halfway in, again to the same side. I'm putting it to my right here. Pull it out. So I've got two holes that are tangential. Now if you got it completely emptied, you're going to want to put some water back in. The easy way to do that, turn on the sink and just let some water flow onto it. That force of it just falling that far, put some back in there. And now I've got a little fishing swivel connected to a ring stand. I use a little twist tie and a little piece of string here. And I'm going to, you do not want to pull the can open. We just want the only openings here and here. I think some of you are seeing where I'm going with this. And when you hang it, you want to hang it so the string is right across that center tab. That little rivet is in the center of the can. Conveniently marks it there for you. Okay? There we go. What have I got here? Let's find out. I'm going to light this Bunsen burner. Doesn't need to be a very strong flame. I might turn that up a little bit. Okay? Now, very important premise in chemistry, never heat a closed system. Why? Molecules in there bouncing around faster and faster, pressure building up. But this isn't a closed system. I know the can's not open on top, but it is open on the sides of these two holes. So let's take a look and see what's going on here. If I turn this down some, I can get a nice little controlled spin. We've got ourselves what's called a Hero's engine. It's a one-cylinder engine. Get it? One cylinder? Anyway. But it's a steam engine. Okay? And you can't ask for an easier method for making it there, just a pin and a soda can. But some very important chemistry going on here. I'll turn this off so it's not too distracting. But that'll continue to spin, obviously, until that water runs out. Putting more water in would obviously allow it to spin faster, but you'd have to spend more time heating up that water because water has a very high specific heat capacity to the boiling point. So that was the amount of water in there, maybe about 5 milliliters, just a tiny bit on the bottom. When do I use this demonstration? Obviously, if we're talking about any kind of energy transformations, because look what I've got here. I've got what could be called chemical energy in the way of the methane molecules passing through this hose. They react here, and that gets converted then into thermal energy, the hot gases here. The thermal energy gets converted into the thermal energy of the can, transferred through to the water, heats up, boils, hydrogen bonds being broken. There's so much in there. And as they get broken, of course, the water boils, and the steam comes out through the holes. For every action, there's an equal and opposite reaction. That can was spinning opposite to the way the holes were coming out, right? And we get, finally, mechanical energy. okay? I guess if I wanted to, I could get a little generator going here and have that cranking it, and I get electrical energy, which I might then convert into light energy. You could keep going with this. This is huge. This is where we get our electricity from. Not turbines like this, but the same idea of chemical energy, usually coal, being converted into steam, and that turning turbines, generating electricity. But also just in a historical point of view. I mean, think about it. I picture ourselves as like cavemen and cavewomen, and we use chemical energy in the form of logs to what? Heat our caves, maybe cook our food, but to get us from point A to point B, travel long distances, do work for us, what a huge advantage that affords us. I'm talking, of course, about the Industrial Revolution. Really all based around the boiling of water, being able to let us go from chemical energy to mechanical energy that we can then use to free up our time and come up with demonstrations like this. So, we call it the one-cylinder steam engine. Thank you.